Everybody, welcome to my YT channel again. This is part 3 of redox, oxidation and reduction in acidic solution. So we're just stopping because I have a weak connection. Okay, and using my laptop. Now this is my mobile phone. Okay, so we stopped here, right, for the balancing of the charges. Okay, this one. Okay, we put 5 electrons here because of this balancing the charges, because we're already finished. We already completed the balancing of the number of atoms, this one, right? Hydrogen, manganese, and oxygen. And then we have this balance of charges, as I discussed a while ago in my part 2, redox, okay, in acidic solution. Now it's gonna be like this, 5 electrons. Now this is the reduction. Now we go to the oxidation, which is the loss of electrons, meaning there's an increase of the oxidation number. So this is iron. Okay. So iron tayo, okay. Oh my gosh. So many papers. Okay. I cannot properly breathe. Charot. So I will have to get paper, right? Oh my gosh. I have here so many papers. Okay. And I will get one. Let's continue to the discussion. Later I will be able to rewrite all, okay, but I'll just have to, the oxidation, okay, ferrous to ferric, okay, like this, Fe 2 plus, and then Fe 3 plus, okay. For the Fe2 ferrous to Fe3 plus ferric, there's no issue with the number of atoms, okay? One atom of iron and one atom of iron also on the left and right side. Now take note, in this case, the number of moles is equal to the number of atoms in this case, okay? Because there's no subscript, okay? And there's no, the coefficient are not being mentioned also. There's no variable coefficient beside the iron. So in this case, atom is quantitatively equal to mole. Okay? It's very clear, so balance already. Now, no issue for the balancing of number of atoms of iron. Now, the issue will be the charges. Okay. If E2 plus, so this is 1 times 2. Because this is the charge, right? So 1 times 2. Okay. And then for the ferric, just also follow my fingertip, coefficient, okay? This is 1 times 3. 1 times 3. If not mentioned, that is 1. Okay? So 1 times 3 is equal to 3. Now, so the deficient of charge is in the reactant, in the ferrous. So it's in this case, you will be confused, right? Okay, because this is positive 3, okay, and positive 2. Remember, we need to add number of electrons. Okay? Take note. Number of electrons. Okay. So, number of electrons. So, negative. Okay. Negative. So 2 plus, let's have first assumption, on the spot kasi eh. So 2 plus x, which is negative, is equals to 3. The negative, okay, yes, 2. So that is 2 minus x already is equals to 3. And then negative x is equals to 3 minus 2. Okay, negative x is equals to positive 1. Okay, then x will be negative 1. Right? Negative and negative. So, negative 1. Okay, negative 1 ang x. So, we need to add negative 1 here. Okay, so 2 plus negative 1 electron, it's not impossible. It is equal to 3. Right? We use first the 2 here so that me also confused because, you know, this is very odd. 3 is an odd number. So, you know, it's not very easy to detect. So, I use algebra first, okay, to understand well. I don't use also trial and error method. The more I will be confused. Okay, trial and error means assigning from 2 to 3 and then it will be equal like this. And take note that electrons is negatives. It's so confusing, right? So, we need to do the algebra. Okay, so let's assume first that we need to add electrons in this side, which is 2. Actually, we know that the charge of iron is deficient man siya. So, we will add here. Okay, for the principle. Okay, 2 plus negative x. Why negative? Because electrons is a negative. So, that's why I put automatically negative x. Okay, is equals to 3. So, 2 minus x is equals to 3. And then negative x is equals to 3. Okay, so negative x is equals to 3 minus 2 transpose. So, x is equals to 1. Divide both sides by negative sign. So, x is equals to negative 1. So, that is negative 1 electron only will be added to the ferrous. Okay? So, it will never equal to 3. Okay? Because 2 minus 1 is equals also to 1. Now, let's force to add on the other side. Okay? So, let's add up. Let x, the number of electrons will be added to this side. Okay? Okay? Let's do this individually so that we can understand. If you are really master, then, okay, you can have that. But for me, I'm confused. That's why. Okay? And then, on the spot also. Okay, we have 2 is equals to 3. Okay? Plus x. How many electrons, right? So, let's say plus x. Okay? Now, 2 is equals to, okay, 3 minus x. Okay? Now, we can rewrite that one as 3 minus x also is equals to 2. Algebra lang only, ha? So, 3 minus minus x is equals to 2 minus 3. Yeah. Negative x is equals to 2 minus 3 is negative 1. So, x is 1. So, x is equals to 1. Okay? Like that. So, x is equals to 1, meaning to say, 1 electron will be added here in the 3. So, kung 1 electron will be added to 3, sure ball. Because 3 minus 1 is equals to 2. Now, it will be balanced. As I mentioned earlier, we let x as the number of electrons, and we know that electrons is negative. Even though we get 1 here in the x, but it is negative automatically. We will put that here, negative 1. The other one will never hold through. Okay? So, meaning to say pala siya, we don't really necessary to add in the deficient one in this situation because this is electrons. It will be confusing. It's not proton. Proton is very easy. We will add here 1 automatically to make it equal here. But this is electrons. Okay? Like that. So, x is equals to 1. Then this referring to 1 electron because we let x as a number of electrons. Okay? Even though there's no sign here. Okay? Because we let x as electrons man siya. Okay? So, 3 minus 1 electrons is equals to 2. 2 is equals to 2. So, we need to add 1 electron. Okay? 1 electron or simply electron lang siya. Okay? So, because we are adding here, so we will add in the ferric, not in the ferrous. Okay? So, plus 1 electron in the ferric side. Like this. So, this is for our oxidation. Okay? Ferrous is equals to ferric. Okay, F2 plus is equals to F3 plus 1 electron. Now, bear this in mind. If you balance the charges, we take into account the charges, of course, and there's an electrons added in the equation. Okay? You have to put electrons always. Okay? That's redox. Okay, now, we have this one, and we have also this one, the reduction. Now, we need to add the two, the reduction and the oxidation. Okay. Now, upon adding the two, we need to observe which are common. Okay, like that, and we need to cancel out if it is common. Again, algebra. Okay, like that. Since we know in a final reaction, we need to eliminate the electrons because our purpose only is to balance the charges, and in the end, we don't incorporate the electrons already. Okay, the last step. Okay, so we need to cancel out the electrons. So all we have to do, we go to the number of electrons which is small in the oxidation, which is electron only, and multiply all the quantities with 5 to make equal with this one so that we can cancel that out. Okay, now we have, my goodness, charot oy, katugo na kay ko, wow. So ganun siya. So we have multiply by 3 ha. So ganun siya. So 3 ferros, 2 plus lahat sa ferros. So we have 5 ferros, sorry, kay 5 ba nag-equal? So 5 Fe, 3 positive plus 5 electrons. Okay, ganon. And then we have also, okay, 5 electrons plus 8H positive plus NNO4 negative is equals to NN2 plus 4 moles of water. Okay. Now we add the two, the oxidation and reduction. So like this. Of course, adding the two, meaning you have to add the reactant in the oxidation to the reactant of the reduction. The same thing, product in the reactant plus the product of the oxidation. It's gonna be like that so that you will not be confused. Okay, 5 Fe2 positive plus 5 electrons is equals to H plus permanganate, okay, is equals to manganese, ginoo ko, 2 plus 4H2O, okay, plus 5A ferric, 3 plus 5A electrons, okay. Ang 5 electrons cancel siya kay common man siya, okay, cancels that out, okay. So our final reaction will be this one. For redox in acidic solution in this reaction here. Okay? Where's that our original reaction? Oh my gosh. Oh my gosh. Saan na yun? Okay, this one. In MnO4 negative, ito. Look at the unbalanced equation first. Okay? And the balance 1. So this is our final equation. If E2 plus 8H plus MnO4 negative plus Mn2 plus 5 ferric plus 4H2O. So this is acidic solution. Why? Because you add hydrogen plus hydrogen. This is an identification of an acid. And the water also on the other side. Okay? Because an acid has always water to add with it. Okay? Like that. Okay, so that's it. Okay, so that's the 5E positive 2H plus permanganate and 2 positive plus 4H2 plus 5Fe3 positive. Ganon siya. Okay, ito na siya. We don't add OH because this is a redox in acidic solution. Okay, so now we need to distinguish now between the redox in basic solution and acidic solution. In basic solution, the same steps except that the last final chemical reaction will be added with OH negative. Okay? And then the other also, for the acidic, the final step will add H plus and water. Okay, that's the difference. But the steps is just the same. First, we need to balance the chemical reaction. Second, we need to determine the oxidation and reduction, identifying which element is reduced and oxidized. Okay, number 3, we need to have the half reaction. Okay, half reaction meaning we need to balance first the number of atoms and then after that the number of charges. Okay, but take note, we need to add water in every deficient of oxygen atom in each side, and then we need to add also H plus to compensate with the hydrogen upon adding water, something like that. Okay, number 5, we need to add the 2. Okay, after balancing the number of atoms and balancing the charges. Okay, and in balancing the charges, we need to add electrons for that. And adding the 2, we need to cancel the electrons. That's why we multiply it with certain figure so that we will eliminate the electrons for the purpose of we don't have electrons to be incorporated in our final reaction. There's no reaction that have electrons in the final reaction. The purpose only to that is to determine the balancing, that it's become stable throughout the chemical reaction. But in the final reaction, there's no electrons anymore to be added in the chemical equation, whether it could be a redox in acidic solution or a redox in a basic solution, something like that. Okay, that's the procedure. But to be honest, I did not understand this very well when I was in my BS chemical engineering, when I was in my college years. Okay, because I'm confused. Okay, just now. Okay, because I really, dig why it becomes like that. And even before, I'm confused with the trial and error method by the instructor, because they always put numbers to make it equal like this. Okay, and I think most of the videos are doing like that also. Okay, even though in YouTube, okay, they will never say let X the number of the charge of this element, let X the number of atoms in this element, let's do the algebra. They will never say in their explanation, because they think the students can understand very well if they assign numbers so that to equal like this. But that is not a good explanation really. Okay, you need to solve for the value of X and applying the theoretical aspects, the scientific law. Okay, like this. Okay, so let X like that. But honestly, it will take a longer time to do the discussion in that manner. Okay, but that is only for the first introduction. For the second explanation, no need to do that. Okay, for the purpose only, in order for the students to understand. Okay, so meaning to say, balancing the chemical equation is not difficult. Okay, confirmed, proven, and tested. If you know the law of conservation of mass, that the number of atoms in the reactant will always be equal to the number of atoms to the product. The number of charges in the left or the reactant will always equal to the product. Okay, for the redox, something like that, then you will never be confused. Okay, but just take note, systematically, because sometimes, like me, when I put the charges, only clerical error. Sometimes I put -1. Okay, because too much fast in explanation, but that is only a minor thing. Okay, but the major thing is we need to understand the basic foundation, how to balance the chemical reaction or chemical equation. Could either be the redox chemical equation or chuba-chu-chu, something like that. Okay, the rest will follow, and then you have to determine the configuration, the element configuration in the periodic table, because it matters a lot also. Okay, my gosh. We cannot memorize the periodic table, of course, but we need to understand the different, what you call this one, behaviors. For example, from top to bottom, what will happen to the atomic radius, something like that. Okay, and then from bottom to the top, what will happen to the electron ionization potential or the ionization energy. Okay, would it be the ionization energy at the top is higher than the ionization energy of the bottom, or whether the ionization energy of the element at the top is higher than the element, okay, ionization energy at the bottom, because it will be arranged like that. And there's also a principle like that. As you go down, the ionization energy will become higher, the atomic radius will become low, something like that. And then what is the other one? Electron affinity. May ganun ba yun? Parang may ganun. Ionization energy, di ba mayroon? Meron din siyang electronegativity. Sorry. Not electron affinity. Electronegativity. Pareho ba siya? Electronegativity or electron affinity? Okay. As far as I could remember, I think so. But the right term really is electronegativity. Okay. The electronegativity will rise if going to the down like this. And then in horizontal also, what will happen to the electronegativity from left to right? What will happen to the ionization energy from left to right? What will be happening to the radius of this element? Will it become big or not? What will be happening to the atomic weight or molecular weight as we go from left to right, as we go from the top to the bottom? What will happen to the molecular weight, to the atomic weight, to the atomic number, like that? And this all come in the examination, board examination, something like that. Okay? Then you have to determine, because in the first page in the chemical engineer's handbook, there is a periodic table there. Because you cannot memorize everything. All you have to do is to understand the relationship, okay, of those electronic configuration of each element in the periodic table. I think there's 300 plus elements in the periodic table. I don't memorize what's plus. 300 plus, something like that, okay? And then it's Mendeleev who discovered Dmitry Mendeleev. As far as my stock knowledge will, remember, it's Dmitry Mendeleev that discovers the arrangement of this elements like that, the behavior of the elements, okay, that he knows this really gonna be the properties of one element or another element. It's been arranged properly, something like that. Dmitry Mendeleev, okay. So maybe it will come out also in the examination. Who discovered the electronic configuration, arrangement of the element? So A, okay, John Dalton. B, Copernicus. C, Dmitry Mendeleev. Ganon. Okay. D, Antoine Lavoisier. Charot. Antoine Lavoisier is the father of modern chemistry. Okay. And Alexander Newberg is the father of biochemistry. Okay, there's a difference between biochemistry and modern chemistry. So if the question like this, who is the father of biochemistry? It's not Antoine Lavoisier. It is Alexander Newberg. Okay, like this. And the father of modern chemistry is Antoine Lavoisier. Okay, something like that. Because chemistry is all about the discovery of Antoine Lavoisier. Okay, the orange one, written by Mr. Fred Moore, so like this in general chemistry. So it's there also, the periodic table. I think it is in the last portion. But sure, in the chemical engineer's handbook, it's in the first page of the cover. Okay, it's in there. Everything is highlighted there. Okay, like that, because we cannot memorize all the elements. Okay, we can only memorize the most common one. Okay, gosh. And also the artificially prepared radioactive substances. Those are plutonium, uranium, like that. Remember that one, artificially prepared elements. Okay, those are in the lower portion of the periodic table. You have the transition elements, ganon. Okay, non-metals, metals. Okay, halogen family. So the halogen family are talking about the halides. Okay, those are chloride, fluoride, like this, nitride, okay, with -1 charge, the halide group. Okay, if we say halogen group, that is chlorine, fluorine, bromine. If it is halide group, chloride, bromide, like that. Okay, it's having a charge of negative. So if we say halogen, there's no charge negative. It's only free state as chlorine. So meaning to say, neutral, zero charge. Okay? I hope the instructors will discuss like this, okay? Because me also, when I was in college, I cannot understand very well. If it is chlorine, what is the charge of chlorine? Because then I will ever say, if it is chlorine, that is existing in a free state. That means the charge is zero. That is having a neutron, okay? So meaning to say, chlorine have a charge of zero, and that is a neutral charge for chlorine. Now, if it will exist as a chloride, the charge will become negative. I hope the teachers will explain like that. Okay? And then if it will exist as a chlorine gas, there will be no charge at all. Something like that. Okay? Because it is diatomic gas. Chlorine gas. Okay? It will only have a charge negative when it will exist as a chloride. So meaning to say, chloride, chlorine gas, and chlorine. So it's different three things. I hope the teachers will explain like that so that the students can understand really the behavior of one element. Okay? Because me also, I'm troubled before. I cannot really understand well also. Okay? Something like that, and just, later I found out, oh, it's gonna be like this. Okay, so, so tutuwaron pa siya. So, of course, we can understand. Okay? Something like that. Okay, so there's a lot of things to remember. Oh my gosh. Okay. Hindi wala akong coffee, in fairness. Oh my gosh. Oh my gosh. Okay. So, gano'n lang siya. Mga common lang siya talagang nyo. Memorized. Memorization talaga, okay? Because I'll tell you honestly, chemical engineering is more on 70% plus memorization. Really. And it's only 30% all of the problem solving. Okay? Because if you understand the memorization of the concepts, the foundations, then you can easily derive equation. Because you memorize the basic formulas and you have to connect that, right? Okay, something like that if it is directly proportional with each other. And then sometimes you can create your own formula. Something like that, okay? Because you memorize different kinds of formula. For example, Albert Einstein for the law of the light, okay? The movement of the light particle, the speed of light in a vacuum. Remember that one? 3 times 10 to the 8 meter per second. Okay, that is Albert Einstein discovery, right? The theory of relativity. E is equals to mc squared, something like that. And we have also formula a lot of E in the thermodynamics, right? Remember that one. But of course, your instructor will never teach you like that. It will just push you to have your own initiative to connect the formula so that you can have your own formula, something like that. So you can equate that with another formula for the energy. For example, kinetic energy is also sometimes denoted as E only. Kinetic energy. And then the kinetic energy also, it can be also incorporated in the ideal gas law, which is the PV and RT. Okay? And then E, we have also ideal gas law in terms of energy. And then we will equate that to Albert Einstein theory of relativity. So E1 is equals to E2. And then we can have another formula also. And then we can cancel, blah, 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 and like that. And we can determine, even though the gas have the temperature, PV and RT, right? The number of moles, the universal gas constant, the R. Okay, the letter atmosphere, the degrees Franklin. Remember that one? The value of R, 0.0 to blah, 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 letters moles per liter, degrees Kelvin. Remember that one? The value of R in PV and RT. Okay, now, even though the question have speed, okay, and then there's a gas also. For example, oxygen go to the pipeline, blah, 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 with a velocity of what is the pressure, or what is the area of the pipe. And then you will be wondering, oh my gosh, what's the connection of velocity on the gas? Okay? Because we are only familiarizing the gas through the number of moles, okay, the mole fraction, okay, the air, the temperature, the pressure, but we are not used to having velocity and speed. So it will be connected there because there's also a relation of the formula of Albert Einstein, which is in energy is equals to mc squared. C is a speed of light or the velocity. Okay, so something like that. You can compute for the velocity of the gas or the speed of the gas inside the pipeline, something like that. Okay, even though there's an area like this, very difficult sometimes. Okay, and then if we stick to the present topic and then we will never connect to the other topic, then we will never think of that other topic also. That's the common mistakes I have when I was in college, because I focus only to the present topic and I forgot that it should also be connected the previous topic, so that we can have our own formula by connecting the dots or connecting the various formula, something like that. Okay, very clear. Charot! Oh my gosh. Okay. Oh, 30 minutes and 46 seconds. Oh my gosh. Time check, bro, Toyota. Powdered Alaska milk. Anong oras na siya? Oh my God, it's already morning. Oh my gosh. Thank you so much for watching this live streaming, and I hope you enjoy while listening, and then you can share a little bit with your friends, and you can also have your own vloggings if you wanted to, if you have your own channel, and you can like, you can comment, and then subscribe my YT channel. Thanks to others also subscribing my YT channel, because it increases also. Okay, I monitor my subscribers, and it's increased a little bit. Okay, thank you so much for that. Okay, and click the notification bell for some newest updates of I Am Singer, Eternal Voice. Bye bye, God bless everybody. See you later. Gosh, talaga.